NENOMATICA, where mathematics meets YouTube excellence. Welcome to this video about the square of the difference of two terms, also known as the difference of squares formula. This is a fundamental algebraic identity that is used extensively in mathematics. Let's start with the general form of the identity. For any two real numbers, a and b, the square of their difference can be written as a squared minus 2ab plus b squared. Now, let's prove this identity step by step to understand why it's true. We'll use algebraic manipulation to expand the expression. We start with the left side of our identity, the square of a minus b. The first step is to rewrite this as the product of a minus b with itself. Next, we'll use the distributive property to multiply each term in the first parenthesis by each term in the second parenthesis. This is also known as the FOIL method. First, outer, inner, last. Now, let's simplify these products. A times a is a squared. A times negative b is negative ab. Negative b times a is negative b times a is negative ba. And negative b times negative b is positive b squared. In the next step, we can simplify further because a times b equals b times a for real numbers. So negative ab plus negative b a equals negative 2ab. And so we've shown that the square of a minus b equals a squared minus 2ab plus b squared. This completes our proof of the identity. Now let's work through an example to see how we can apply this formula in practice. Let's expand the expression to x minus 6 squared. We can apply our formula directly by identifying that it equals 2x and b equals 6. Using our formula, we get a squared minus 2ab plus b squared. That means 2x squared minus 2 times 2x times 6 plus 6 squared. Now let's simplify. 2x squared equals 4x squared. 2 times 2x times 6 equals 24x. And 6 squared equals 36. So our final answer is 4x squared minus 24x plus 36. Let's verify this result by expanding the expression using another method. We'll multiply 2x minus 6 by itself using the FOIL method. Using FOIL, we multiply. First, 2x times 2x equals 4x squared. Outer, 2x times negative 6 equals negative 12x. Inner, negative 6 times 2x equals negative 12x. Last, negative 6 times negative 6 equals positive 36. Simplifying the products, we get for x squared plus negative 12x plus negative 12x plus 36. Combining like terms, we get for x squared minus 24x plus 36. This gives us the same result that we found using the square of difference formula. This verifies that our formula works correctly. Now that we've seen the proof and an example, let's highlight some key aspects of the square of difference formula using our multicolor highlighting system. Let's apply this identity to solve some examples. For our first example, let's expand x minus 1 squared. To expand this expression, we'll use the square of difference identity. According to our identity, we'll substitute a with x and b with 1. This gives us x squared minus 2 times x times 1 plus 1 squared, which simplifies to x squared minus 2x plus 1. Let's look at our second example from the problem. Now we'll expand a minus 3b squared. For this example, we'll again apply the square of difference identity. According to our identity, we'll substitute a with a and b with 3b. This gives us a squared minus 2 times a times 3b plus 3b squared, which simplifies to a squared minus 6 plus 9b squared. Let's examine another example from our problem. Now we'll expand to a minus 3b squared. For this expression, we'll once again use the square of difference identity. According to our identity, we'll substitute a with 2a and b with 3b. This gives us 2a squared minus 2 times 2a times 3b plus 3b squared, which is 4a squared minus 12a plus 9b squared. Let's look at our fourth example from the problem. Now we'll expand for a minus 2 squared. For this expression, we'll use the square of difference identity again. According to our identity, we'll substitute a with 4a and b with 2. This gives us 4a squared minus 2 times 4a times 2 plus 2 squared, which is 16a squared minus 16a plus 4. Let's look at our final example from the problem. Now we'll expand 999 squared. For this example, we can use a clever approach. We'll rewrite 999 as 1000 minus 1. Then we can apply the square of difference identity with equals 1000 and b equals 1. This gives us 1000 squared minus 2 times 1000 times 1 plus 1 squared, which is 1 million minus 2000 plus 1, and the final result is 998,001. This last example demonstrates how the square of difference identity can be a powerful tool for mental math calculations. Welcome to our math lesson. Today we're going to learn about squaring binomials. This is a fundamental skill in algebra that will help you simplify expressions and solve problems more efficiently. Let's start by understanding the rule for squaring binomials. When we have an expression in the form of a plus b and we want to square it, we get a squared plus 2 times a times b plus b squared. We can visualize this with a formula. Similarly, when we have an expression a minus b squared, we get a squared minus 2 times a times b plus b squared. Notice the middle term has a negative sign now. Let's work through our first example. We have 4x minus 3y, all squared. To solve this, we'll use our binomial squared formula. First, we need to identify our terms. In this case, a is 4x and b is 3y. Now we apply our formula, a squared minus 2ab plus b squared. Let's substitute our values. A squared is 4x squared. 2ab is 2 times 4x times 3y, which is 24xy. b squared is 3y squared. When we simplify this, we get 4x squared is 16x squared. 2ab is negative 24xy. And 3y squared is 9y squared. So our final answer is 16x squared minus 24xy plus 9y squared. Let's look at another example. We have 3x squared minus 2x, all squared. First, we identify our terms. A is 3x squared, and b is 2x. We'll use the same formula, a squared minus 2ab plus b squared. Let's substitute. A squared is 3x squared squared, which is 9x to the 4th power. 2ab is 2 times 3x squared times 2x, which is 12x cubed. b squared is 2x squared, which is 4x squared. When we simplify, we get 9x to the 4th power minus 12x cubed plus 4x squared. So our final answer is 9x to the 4th power minus 12x cubed plus 4x squared. Now, let's try a more interesting example. We need to calculate 9,999 squared. This might seem challenging, but we can use a clever approach with our binomial formula. Let's rewrite 9,999 as 10,000 minus 1. So a is 10,000 and b is 1. Now we can apply our formula. A squared minus 2ab plus b squared. Let's substitute. A squared is 10,000 squared, which is 100 million. 2ab is 2 times 10,000 times 1, which is 20,000. b squared is 1 squared, which is 1. When we simplify, we get 100 million minus 20,000 plus 1. So 9,999 squared equals 99,980,001. Let's look at one more complex example. We have 2 to the power of 1/5 minus 2 to the power of 0.5, all squared. Here, a is 2 to the power of 1/5, and b is 2 to the power of 0.5. We apply our formula, a squared minus 2ab plus b squared. Let's substitute. A squared is 2 to the power of 1/5 squared, which is 2 to the power of 2/5. 2ab is 2 times 2 to the power of 1/5 times 2 to the power of 0.5. b squared is 2 to the power of 0.5 squared, which is 2 to the power of 1. We can simplify the middle term by using the properties of exponents. 2 to the power of 1/5 times 2 to the power of 0.5 is 2 to the power of 1/5 plus 0.5, which is 2 to the power of 7/10. So the middle term becomes negative 2 times 2 to the power of 7/10. Our final answer is 2 to the power of 2/5 minus 2 times 2 to the power of 7/10 plus 2. Let's look at some examples and see how to solve them step by step. Let's begin with our first example. We're going to evaluate the product of two binomials, open parenthesis 2, a minus 3, b close parenthesis times open parenthesis 3b minus 2, a close parenthesis. Our first step is to recognize something important about these binomials. Notice that 3b minus 2 is the negative of 2a minus 3b. So we can rewrite this as the negative of open parenthesis 2a minus 3, b close parenthesis times open parenthesis 2a minus 3, b close parenthesis. Now, we can see that we have the negative of a perfect square. We can rewrite this as negative open parenthesis to minus 3b close parenthesis squared. Now, we need to expand this perfect square using the formula. A minus b squared equals a squared minus 2ab plus b squared. In our case, a is 2a and b is 3b. Let's simplify each term inside the square brackets. The first term is 2a squared, which equals 4 squared. The middle term is negative 2 times 2a times 3b, which equals negative 12ab. The last term is 3b squared, which equals 9b squared. Finally, we distribute the negative sign to all terms inside the brackets. This gives us negative 4a squared plus 12ab minus 9b squared. Now, let's look at our second example. We want to calculate 99 squared. This is a perfect square, but calculating it directly might be tedious. Let's use a special technique. First, let's rewrite 99 as 100 minus 1. So 99 squared becomes open parenthesis 100 minus 1 close parenthesis squared. Now we can use the same perfect square formula as before. A minus b squared equals a squared minus 2ab plus b squared, where a is 100 and b is 1. Let's calculate each term. 100 squared equals 10,000. 2 times 100 times 1 equals 200, and 1 squared equals 1. Finally, let's add these terms together. 10,000 minus 200 plus 1 equals 9,801. So 99 squared equals 9,801. For our third example, let's evaluate the difference of squares. Open parenthesis x plus 2 close parenthesis squared minus open parenthesis x minus 1 close parenthesis squared. First, let's expand each squared term using the perfect square formulas. For x plus 2 squared, we use a plus b squared equals a squared plus 2ab plus b squared. For x minus 1 squared, we use a minus b squared equals a squared minus 2ab plus b squared. Now, let's distribute the negative sign to the second set of brackets. This gives us x squared plus 4x plus 4 minus x squared plus 2x minus 1. Now, let's combine like terms. The x squared terms cancel out, and we get 6x plus 3. Thank you for watching. Don't forget to like, subscribe, and hit the bell icon for more math lessons. NENOMATICA, where mathematics meets YouTube excellence.